Hey class, okay, so welcome to our very first, hopefully successful YouTube version of our quick and dirty for stoichiometry. Okay, so for this one's going to deal with mole-to-mole stoichiometry and mass-to-mass stoichiometry. Now, if you feel comfortable, that's totally cool. Go ahead and skip to wherever it is that you're having the most difficulty, okay? So today, I'm going to start with defining, well, what exactly is stoichiometry? I think that some of you guys get a little confused. So all that it is just the quantitative relationship. Now quantitative, all that means is amount, is quantity, like amount. So pretty much dealing with numbers, okay? So I'm saying that I have 16 eggs and I want to figure out, well, if I have 16 eggs, how many omelets could I make? Alright, using different relationships. In this case, we'll say that for every 2 eggs, I can produce 1 omelet. So can anyone tell me if I have 16 eggs, how many omelets I can make? Yeah, you guess it, it would be 8. Okay, so using these relationships, we can determine, well, if I have a certain amount of A, how much of B would I actually make or have? Okay? So for us, the most useful reference is that, well, I have some amount of compound A, and we'll say that it's water, or that it's hydrogen, okay? I have some amount of compound of hydrogen. Well, we know that hydrogen reacts with oxygen to create water, and so using the relationship between hydrogen and water, I can give you any amount, whether it's in grams or whether it's in moles, and you can tell me, well, how much water would I produce? Okay? This is where the mole ratio comes into effect. So do you guys remember? Using this again. If I asked you what the mole ratio is between hydrogen and water, what would it be? Now feel free to pause at any time if I ask you guys a question to see if you can do it on your own, okay? So in this case, if I wanted to know for hydrogen over water, it would be for every 2 moles of hydrogen, I would have or produce 2 moles of water. Now this is what I expect every single time, okay? I expect not only just numbers, I also expect the units along with the compound, okay? Remember my example. If I told you the number 26, could you tell me what I'm talking about? Or the number 52, okay? So if I told you those things, you wouldn't know. So if you just write down 2 over 2, I have no idea what you're talking about, okay? So make sure that when you do your work, you're very precise about what you're talking about, okay? So, stoichiometry, just to reiterate, it's saying that I have an amount of compound A, and using a relationship, I'm figuring out how much compound B would I produce, okay? So, let's do a problem, alright? Let's start with just basic mole-to-mole stoichiometry. I'm pretty much saying that given however much of compound A I have, I want to know, well, how much compound B would I create? Okay? So I'm going to use the example given on the quiz question. Now I had multiple versions of the quiz, so this might be a different number than what you're used to, but that's okay. Okay? So just go with it. So feel free at any time to pause it. If you want to try and do this problem on your own before I go through it, then pause me right now so that way you can work through it and then you can check your answer after you're done. Okay? Now, as a nice little strategy, what I like to do is I like to write what am I given and what is it that I want to find. Okay? So in this question, I have 2 potassium chlorates that yield to 2 potassium chlorides and 3 oxygens. Now remember, the coefficients are talking about moles, okay? So within here, I can use the relationship that for every 2 moles of potassium chlorate that I have, I would yield 2 moles of potassium chloride or 3 moles of oxygen. But remember, the point is that they're in moles, not grams. So make sure you don't get those confused. So either way, so back to my question. I say, well, what is the total number of moles of KClO3 needed to produce 12 moles of O2? So can you tell me what my given is? Yes, it is 12 moles of O2. Very good. Okay? And then can you tell me what it is that I want to find? Very good. It's moles of KClO3. Okay? Now we're going to use this as our foundation in order to figure out what exactly it is or how to go about this problem, okay? Alright, so for space, I went ahead and I moved up my given and my want up here, okay? So the first thing that we start with is, well, what's my given, okay? So we wrote it down. That's 12 moles of O2. Now, if I'm going to go from moles of compound A to moles of B, what is it that I'm going to use? Yes, you guessed it, molar ratio, okay? So, between what 2 compounds am I going to find my molar ratio between, okay? Yes, so it's going to be between KClO3 and O2. Remember, use what you have. Why would I talk about KCl if it's not even addressed in my problem, okay? So the mole ratio that I'm going to deal with is between KClO3 and O2. Now, because I want to find moles of KClO3 are going to go on top, okay? And because what I'm trying to get rid of is O2, that's what's going to go on bottom. Now, what matters is what are the numbers that are going to go with it. Remember, those belong to the coefficients. This is saying that for every 2 moles of KClO3 that I decompose, I would produce 3 moles of oxygen, okay? Now, if you multiply it across, let me go ahead and erase this. You multiply it across, the math for this is just so. It's 12 times 2 over 3. So that would just be 24 over 3, which would just equal 8. Now remember, it's 8 moles, and it's 8 moles of what? That's right, KClO3. Okay? So make sure that you follow these steps one by one. Go ahead and pause if you need to, but I'm going to keep going, okay? So, now that's just plain mole to mole. That says that I'm giving you moles A, and I want to figure out how much of moles B is. However, like I said, it's not always easy to go from moles to moles. That's not how it's going to really work, okay? So most of the time I'm going to give it to you in masses, okay? I'm going to say determine the amount of grams, so grams of compound B based on the mass of compound A, okay? So my given is compound A and my want is grams of compound B, okay? Every time. Now, we learned 3 easy steps in order to go between mass of compound A to mass of compound B, okay? It's mass to mole, mole A to mole B, and then mole to mass, okay? Now, if you can remember these quick and easy steps, then you should be ready to go. Now, what you just need to remember, though, is that if I'm going to go from mass to mole, what conversion factor am I going to use? Very good. Molar mass, okay? This is grams per mole. And if I'm going to go from mole A to mole B, very good, molar ratio. Okay, and that's going to be dependent on what your compound A is and what your compound B is. And then lastly, molar mass again. Now remember, when you switched from compound A to compound B, we now leave compound A behind, so the molar mass is of compound B, not of compound A anymore, okay? So just remember these easy steps, okay? 1, 2, and 3. Anytime I say how much of compound A is produced, these are the steps that are involved, okay? All right, so let's do a problem. Let's go ahead and do the one from the quiz. All right, and what I want you to do is to go ahead and write down, based on my question, how many grams of HCl would be required to produce a total of 4 grams of H2. Tell me what is my given and what is my want. All right, so my given is 4.0 grams of H2. Okay, and my want is grams of HCl. Now notice how I put grams, so that way I know that this is what my end result should be. My units need to be in this in order for them to be correct, okay? So let's keep going. So my beginning, because my given is 4 grams, I'm going to start with 4.0 grams of H2. Now remember, what's the first step? Very good, mass to mole. So in order to go from mass to mole, I'm going to divide it by its molar mass of hydrogen. Now remember, it's H2, so it's not 1 mole, not 1 gram, but it's 2 grams per 1 mole. And remember, the molar mass is independent of your equation. This has no effect on your molar mass, okay? So make sure that you don't include it. But moving on, we'll now find out that we have 2 moles of H2, okay? However, is that what I want to find? No, I want to find HCl, which means that I'm going to do moles to mole conversion, starting with my new given, which is 2 moles of H2. And like we said, in order if we're going to go from mole to mole, we're going to use the mole ratio. Now because I want to figure out moles of HCl, that's going to go on top. The bottom's going to be moles of H2. And based on my what? Coefficient or subscript? Very good, coefficient. I find out that I have a 2-to-1 relationship. Now, if it's easier for you to figure this out first and to figure out the mole ratio first and then insert it into your T-chart, that's totally fine. Go ahead and do that. Whatever way is easiest for you. This, to me, it just makes more sense. But if you like to put that it's 1 mole of H2 per 2 moles of HCl and then insert it, that's cool too, okay? But let's keep going. So now my moles of H2 cancel out, so all that I'm left with is 4 moles of HCl, okay? But did I want it in moles? I have the right chemical, but do I have the right units? No. So I need to step one more step, and that's going to be from moles to grams. And when you guessed it, we're going to use molar mass again, but remember now it's for HCl. So let's go ahead and bring this home. My new given is now 4 moles of HCl. Actually, you know what? I'm going to go ahead and write it on a new piece of paper. So it's 4 moles of HCl. And so what am I going to insert here? Very good, the molar mass. Now the molar mass is 36 grams per mole. So how am I going to insert that into there? Very good. The 36 grams is going to go on top, the 1 mole on the bottom. These two cancel out, and I'm left with 144 grams of HCl. This is my answer, okay? Now I understand that it may seem a lot of steps, steps 1, 2, and 3. I think step 1, 2, and 3. However, the more practice you get, the quicker it will be, okay? Now, if you have any more questions, I'll still have tutoring on Wednesday, just right before the test. So stay calm and just remember, just keep practicing, okay? All right. Bye-bye.